Okay, this question comes in two parts. First part is simply asking us to differentiate a function. The problem being, to start with, is we've got y equals 3x squared, but this second part, the plus 2 over x, is something we need to be a little careful of. We need to change that into index form first, rather than having it written as an algebraic fraction. So just, we carefully do that. It's 2 times, it's the x to the power of negative 1. And then we have our minus 4 afterwards. Now, just be careful with that algebraic fraction. It's the minus 1 only applies to the x, not to the 2. And now it's in a form that makes it a bit easier to differentiate. So dy by dx, we differentiate y with respect to x. So we do this term at a time. And differentiation says you multiply through by the power and raise the power by 1. So when I multiply through by 2, I get 6x. And when I reduce the power by 1, that's x to the power of 1. But we don't tend to write that. We just leave it as 6x. Being a bit careful here, because when I multiply through by the power, minus 1 times 2 is negative 2. And when I reduce the power by 1, minus 1 reduced by 1 is actually negative 2. When I differentiate negative 4, I get 0. When you differentiate a constant, you get 0. And so that's our dy by dx. What might be useful is to rewrite the negative index in fractional form. So it's 6x minus, notice the 2 has no power attached to it, so it stays on top, 2. It's only the x that's to the power of negative 2, so that means over x squared. Now, in any exam, you'll probably get your marks for this second line here, getting this here. But to help us out later on when we use this gradient, it's easier to rewrite it in back as a fraction. Because the second part of this question says, hence find the equation of the tangent to the curve y equals 3x squared plus 2 over x minus 4 at the point 1, 1. Now, again, a tangent is just a straight line. And we've used this equation before. Y equals mx plus c is the equation of a straight line. We need to be able to find the gradient of that line. But dy by dx helps us get the gradient. And we also know at the point 1, 1, dy by dx is equal to, well, if we put the x value of 1 into our gradient, we get 6 plus, that's 6 minus 2 over 1, which is just 6 minus 2, which is 4. And so at the point 1, 1, that is our gradient. And so the equation of our line is based on y equals 4x plus c. Again, we're given a point 1, 1. So at 1, 1, the value of y is 1. The value of x is 1. So 4 times that is 4. And we can use that then to find what c is. C is equal to negative 3. And so overall, let's rewrite the equation of our line, because it's y equals, the gradient is 4, and the y-intercept is minus 3. And c is a constant, so it won't change. And so we can write that as our equation of the tangent.